Hi guys, like now we are presenting our 502 SCR 502 project. Our we built a language. Our language name is MATLAN. It's a shortcut for matrix language. Mainly it implements matrix operations as first class citizens. Like in many mainstream languages, this is a feature which is missing. Like when we developed it in C++ with Bison and everything. And our object is to design and implement a custom programming language which mainly deals with matrix operations. And our key features are lexer, parser, and it covers all the operations like either matrices or Boolean operations or loops or any conditionals like if and else. And also we use tools Flex, Bison, C++, and Make. And coming to our language grammar, and we used EBNF, and also we used plus star, star, dot star because it binds tighter than the addition like plus, and ternary has low precedence. And coming to matrix specific rules, matrix syntax, our matrix syntax is mainly in parser.y. Here dimensions must be numbers for in our language. And literals are in language literals are in matrices. There we used matrix literal as our tokens, and we also avoided dangling else ambiguity in our grammar structure. And also coming to lexer analyzing, written matrix keyword mainly we use because to ensure that matrix syntax is unambiguous in our grammar. And coming to written element times, we handled this in parser file with percentage left declaration to bind tighter than the edition. And coming and we also used unique like YYLYL, that is mainly concerning our ownership, not ownership for unique, and also for string conversion, memory efficiency, and error case handlings. And we also covered all the required tokens, and there are no memory leaks. Coming to parser and AST, the like in a for our case, the parser enforces the operator precedence star, dot star, or before plus through Bison's declarations. And here each grammar rule constructs corresponding ACT nodes such that it notices how territory nodes stores the child expressions. The AST nodes handle their own memory cleanup via virtual instructions.
Yeah, coming to the runtime, we developed the test cases for this, and I used the Linux for the execution. So the test case shows like the comparative operators in the example, like if the A is greater than B, or like will this work like this a ternary operator, and it has successfully executed. So when we build the language, we should clean the make first, like to make sure this is the compiler is properly made. With the make command, we have used the make file to like give the command in the make file, and use the make file to generate the parser and lexer files. And it supports generally Mac and Linux. So dependencies like you should have Flex 2.6 plus and Bison 3.7, and there is dependency you should install Bison for Mac with Brew, or you can use sudo apt get install Bison. So yeah, in previous like the challenge we faced, like we had the memory loss challenge where, like you can see the like the memory was leaking. So we use delete keyword to come up with this issue. And there was also the matrix size was mismatch, which we used the debugging tool to fix that issue. So like future development, like future scope will be like enhancing the language feature. Like we should enhance the features and tool improving, and we can use the VS Code extension instead of the like building it from straight up. And there needs to be like AST should be easy to add new nodes and value and systems. Union can be extended. Yeah, in conclusion, like we fully built the compiler, like fully built the language, and there are Lexer parsers, AST, which we built it in the C++, and it supports all the operations, matrix operation, control flow, loops, and whatnot. So we had this collaboration with our whole team. So the team contributions are like the Amish was responsible for updating README, work on compilation issues, make file, and Shivam has designed the Lexer and initial implementation. And me, Yasser, I designed the parser, pre and initial implementation. Well, and Litika defined the grammar and help us to like troubleshoot the errors and test case. And we'll go to the execution now.
Is my screen visible?
Yes, invisible.
Yeah. So for Bison and Flex were the main parts for this project. Bison was like, so there are multiple C++ and H files you would see in the project. So um, Lexer was used to define the tokens, and parser was to define the language of a grammar and how it will be processed, how each and every line of the language of our code would be processed. So as you see, there are multiple files. So first we will see Lexer. So here you have defined the digits, letters, white spaces, what all input can be given to the code for a new language, like letters, white spaces, numbers, comments, etc. One of the things, one of the features I would say for this language is that you cannot have an underscore character in a variable name. You can only define your variable name like small x, capital X, or a combination of them like that. And you also have print statements which you can apply in your own code to see the output. Then parser.y is the main language implementation, how it defines the language of the grammar of the language, and many other things. So suppose if you want to run it on your system, we would first have to go into the source folder and then generate a make command. But as you see, I get a error issue on running the make command. So this is mainly due to not setting the path of Bison here on my system correctly. So on Mac systems, the Bison is available on this path, also on this path. If the reported Bison version is less than 3.0, then you must edit the make file for the line generating parser.tab.c. That is this line, which is going to generate all the required files. So, and also for this project, you would need Bison 3.7 plus. So if you do not have that version, you first need to install it on your system. If it is a Mac OS, you can install using brew, or if it is Ubuntu, you can install using sudo apt, and you can confirm the Bison version using this command. So for my system, I would have to change the path here. And now, as you see, each and every file is being generated. The lecturer is going through all the files, the language of the grammar is being checked, and all the required files are being generated. Of course, these are binary files, you cannot open them. You can just see that they are generated. Now, so this means that we have successfully built an interpreter for our language. So now if you want to run any example programs, you can do this using this command, dot matrix line, which is a kind of an executable for a language interpreter. So I would just go into the source folder, access this matrix lang, and then test it on one of my files. So as you see, this is a test file for our language, test1.matlan. Matlan is the extension for our language. So here I've defined each and every, like I'm defining a variable using a normal, it would be similar to definition in C++, and there are no brackets used for like while printing, while using for the print statement. So as you see in this language, it has correctly processed this comparison operator. And similarly, we can generate you can have multiple files, you can test multiple files. You can test the if else conditions, you can test the loops, for loops, while loops, etc., and many things. Now my friend Soham will tell us a little bit more about the test files.
Yeah, hello. Yeah, so uh, hello,
Yes,
audible?
yeah,
Yeah, so the test files we have like 5 test files, and there we have two main like complex test files which are like nested loops, and another is nested if else. So if you go to the nested if else,
yeah,
see here first we are going to if say for x and y is declared, then x greater than 0. Then we like do some calculations, and inside that x we are again checking another thing, y less than 10. So this is a nested if. Same thing if you go down, there would be like multiple of this nested, and there is one where there is only if but no else. That also works. These are like only combinations, like outer is true, inner is false, outer is false, inner is false, like all of these combinations. Can you run this? Okay, here you see the output of the all the if and else commands. As you can see, it doesn't like the program works. It doesn't really cause any issues if we nest loops or like. And this is like all the test cases that are possible, like combinations of if and else that are nested. Now let's move on to the loops, nested loops. Scroll to the top. Okay, this is the top. Okay. So nested loop is, as we know, we have nested one for loop here. So first for loop from 0 to rows, and the second for loop 0 to columns. It's like a matrix. And if you run this, yeah, you can see the like all the runs where the inner loop is running from say 9 to, and the inner loop is from for every run of say r equal to 8, c equal to 1, for r equal to 8, c equal to 2. For every r there is one c. So you can see the interpreter is working correctly, and all the nested loops are working as it should. Okay, I think that's it for our presentation. Thank you. If anybody has any other words.
Also, like we had some issues while building this project, like while running a test case for the for loop, while generating a test case for the for loop, the program would just print the first number and not go through all the numbers. This was due to the approach that we had built for the language. It was not based on parse tree. It was just based on the tokens. So it was rectified by using the use of parse trees, that is AST in our case. Yeah. And also, this AST architecture ensures that the parser and runtime agree on the intermediate form, enabling correct execution for the mainly for the loops, while loop and nested for loops, and each and everything that you just saw. Although we can improve this, but yeah, like we can add more features for this language, but yeah, that's it.
Thank you.
Thank you.